Assalamu alaikum, boys and girls. In the last lesson, we introduced the Ohm's law. We described what is the relationship between a voltage and current, of course, when you have a complete circuit. Now, the following is a setup that can be used to investigate the Ohm's law. So we are going to have this diagram. This is a circuit. I want to draw it here so that you'll be able to understand. Then I'll be able to explain in detail. Of course, if you look at it, you are going to see that there are several operators. All of them are arranged in a particular way. Now, most important here, remember we talk about the Ohm's law. This one talk about the relationship between voltage and current. And of course, we know that for us to come up with the voltage or the potential difference, we need a voltmeter, and for us to come up with a current, we need what we call an ammeter. So ammeter is here. There is a material T, a conductor T. We have a voltmeter. We have a rheostat, our variable resistor. We have the source of a voltage or the potential difference, which is a battery. Then of course you have the switch. Now, I want to remind you that this is an ammeter. It has terminals. These are positive, we have 2. These are 5 ampere, 2.5 amperes. We have the battery, of course, in the cell holder. This one is a switch, which of course we are going to complete the circuit. This one is a voltmeter. This one also has 2 scales. There is a 1, then there is a 3. The 1 scale is the upper scale for us to measure if you are connected here. But since we are connected at the 3, of course we are going to use the lower scale. This one is a variable resistor. This one, of course, we are going to move this knob here so that we'll be able to determine the different values of resistance in terms of what? In terms of current and voltage. Now, one thing you need to note here, you can confirm from where you are that an ammeter is connected in series in the circuit. At the same time, a voltmeter is connected in parallel to the conductor T. In this case, I'm going to have this as my conductor T, then my voltmeter. Now that I have all the operators, I'm going to connect. Now this is my conductor. I'm going to have, these are my crocodile clips, which I'm going to use. These are wires. So one, I'm going to clip it here, like this, then another one here. Now, once I have the conductor like that, which is this point, across it, we are going to have a voltmeter. Voltmeter is actually here. So, I am going to have voltmeter. I put the voltmeter here. Thereafter, I'm going to connect here. The normal way, I remember telling you that you need to come up with what you call a junction. So, I have this. So, we are going to create a junction here. This is a junction. As it goes away, then there we are going to have the voltmeter being connected in series or across the conductor. Remember, this is a very serious experiment, very serious demonstration because it is examinable. You come to KCSE, you never miss a question on this. Current electricity is very, very serious part. No, we have now voltmeter. Now as we go on our left now, we are going to have our rheostat. The rheostat is here. So the rheostat I'm going to connect right here, which is our variable resistor. This is a variable resistor. From the variable resistor, we are going to the battery. Battery is right here. But one thing I want you to note is that this one is negative terminal. This one is negative terminal. So as this side, you have to connect on the negative terminal. Otherwise, you are going to have a deflection on the opposite side. So that's why when you look at the batteries, this is positive, negative, positive, negative. So it means now when I connect here, this is what I need. Otherwise, I'll have a deflection on the negative side. So this is a negative section because of this. Because of the terminal on our voltmeter, so it has to be on the negative part. Then from there, from the battery, I go to the ammeter. Of course, ammeter is here, so I connect here as well. Okay. Then from there, I now go to the switch. Switch is right here. Once you have all the operators, switch does not matter in way either does not contain positive and negative terminals. So you are going to have that. And then lastly, you just have the connection. Okay, now from there you can see that there is the deflection, which is very, very important. Once you connect all the apparatus, once you complete all the apparatus, this is a variable resistor, this is a voltmeter, this is an ammeter. One thing you need to note, as long as the apparatus have been connected well, once you touch, you complete the circuit, we are going to have what? A deflection. You can actually confirm, look at my voltmeter, there's a deflection on my right, there's a deflection. Remember, we are using the 3 terminal, so that now you can be able to see that of course is what? There's a serious deflection. At the same time, there's a deflection on an ammeter. There's a deflection on an ammeter, those lights deflection, or of course there's a deflection in the ammeter. Now once you complete the circuit like this, you have the complete circuit. Now you move on. Close the switch and adjust the current flowing through the conductor T using the resistor to the least possible value. We are saying this. Okay, we tried just to complete the circuit by actually closing the what? Closing the switch. But now we are told, when you are doing this demonstration, one thing you need to note is that you have to follow the procedure, you have to follow the instruction. So you need to adjust the current flowing through the conductor T, which is here. Conductor T is right here. The conductor T is here. So that now, they are to the least possible value. To the least possible value. So meaning, you have to adjust now, you have to adjust your what? Your resistor, so that now you actually record the list. You actually record the list. If I adjust this one to this level, I'm going to have the least possible what? The least possible value. You can actually confirm, look at that. The deflection is very small. Deflection is very small. Why? Because I've adjusted the resistor so that now I obtain the least possible values for both the voltage and what? And current. That's why when I complete this, you can actually confirm from the screen that you look at the voltmeter reading, the deflection is actually deflecting the deflection is slight, very small. At the same time, if you look at the ammeter as well, the deflection is actually very small. You can actually see from the zoom, you can see that the deflection is very small. That is where we need to start from. So you need to adjust that then to obtain the least possible values. Record the corresponding voltmeter reading. Very, very important. So we have to record the voltmeter reading, right? The voltmeter reading you are going to write from where? You are going to read from where? From the voltmeter. Now you move on. Increase the current in steps. Recording the corresponding voltmeter readings. Record your values in the table below. Now initially you recorded the initial value on a voltmeter, the first one. Now at that point the reading on the ammeter was very small, right? Now you need now to do what? You increase the current in the steps, recording steps, so that now you have several values. Now in the next part of the class, I'm going to explain once you have several values from the table, then from there we can come up with what is necessary, which is a graph, then from there we calculate what is required from there. Thank you.